Hello and welcome to our vast customer training webinar on data catalog. We're very excited for this webinar. This actually was a special request from one of our customers to be able to go into this topic. And so we are going to dive in very soon. My name's Kristen Thompson. I'm the Director of Customer Education here at VAST. And so a few notes for you as we start out this webinar. We do have a chat feature where you can ask questions and we will answer them through our Q&A. I will be sending the deck and the recording after the webinar so that you can have that for future use. And it will as well be uploaded to our customer learning portal where we have all of our on-demand learning. I'll put the link to that as well in the chat so that you have that. And without further ado, I am going to introduce our speaker for today, the wonderful Phil Wagstrom from the Office of CTO. So Phil, thank you for joining. I'm not going to take any more time. We're just going to jump right in so that you can get started explaining Vast Data Catalog.
Excellent. Thank you, Kristen. So once again, I'm Phil Wagstrom, Office CTO here at Vast Data, and today we're going to talk about Vast Catalog. We're going to go over what it is, how it generally functions, what some of the use cases are for it, and then we'll go into a few examples as to how you can access it and how you can go through and write queries and integrate this into your environment. So without further ado, I'm going to go through and share out my screen, and we will get started. I'm going to go through off of this screen here, and all right. So what we have here is that we're talking about the VAST catalog. So the VAST catalog is something that is built into the VAST database, or sorry, built into the VAST cluster for this. So kind of the problem that you have, especially when you start talking about large data sets or large arrays or a lot of information, is that how do you determine where your data is? Who's using the space in your system? How is it indexed? Where are the files located? What types of files do you have out there? For a small data set, not such a big deal. But when you start talking about 10 different NFS exports, 100 different NFS exports, 100 S3 buckets, SMB shares, NFS shares, S3 buckets, billions upon billions of files with different owners and different access rights, maybe connected to different networks, it becomes very, very complex to go through and get a good view as to what you have on your system. You have to go through and maybe write some find commands, but a find might work on an NFS, but you need to write something different for SMB, or you need to query things for S3 buckets, that maybe you do or don't have access to. So what the VAST catalog does is that it simplifies a lot of this. The VAST catalog at its core is basically it's an index of the metadata of all the files and objects on the cluster. So we go through, we take a look at the metadata, we snapshot the metadata of it. That includes things like ownership and size and permissions and S3 tags and location within the element store. And we'll take all of that and put this into a database that you can then go through and query via SQL or other methods to go through and get this information. It's something that, again, is internal to the VAST cluster. It does use the VAST database mechanisms that are there, but it is internal to the VAST cluster. It's something that's there without any additional charge. It's part of the platform itself. And this allows you to go through and write, some relatively complex queries. Like say, I want to find all the files or all the objects that are larger than 90 days, or that are older than 90 days and are larger than 10 gigabytes, which are in this particular directory. Or, find all the files created last week by a specific user, or look at rate of change in a directory. For that, or let's say I want to find all the files that are out there, all the S3 objects that have a tag that's a process tag, meaning you've indicated that some work has been done on those. You can also go through and do things like capacity reporting on this. Now, capacity reporting is going to be separate from things like quota reports, because with quota reports you have to set a quota on certain things. This will go through and encompass everything that's on the cluster itself, even if you haven't explicitly called for it or you're tracking it otherwise for that. So, we can go through and also, do things like, I'm going to look at the file extension and rank files like that, or things like that. So it's a very, very powerful tool to go through and use. So again, how does this work? How do we accomplish this? Well, part of the mechanism here is that we leverage snapshot internally. And actually, we leverage snapshotting and the replication engines that we already have within the cluster. And the snapshotting will go through, and at the base level, if we don't want to, we can either go through, we can either snapshot the metadata, which we store in our SCM for that, or we can also optionally include all the data of this as well, such that when we take these snapshots, if we want to actually look at the data rather than just the metadata, we have a record of that too. We can go through and access that if we choose to do so. But effectively, we'll go through, we'll take a snapshot of the metadata, and then we will load that into a database table, which can then be queried. This will happen on a periodic basis. You can set it, up to once every 15 seconds to go through and do that. For that, you can store as as much history as you want to control change, subject to space limitations with that. But you can go through and control that. Now, within the database itself, we'll have one row per object for that. And the metadata, any metadata of interest, such as some examples here, who is the owner, what is the UID of that file, who is the group owner, what's location, access time, modification time, things like that. Those will be stored as columns. So we can query on any one of those. If we have S3 tags, we can actually query based on S3 tags or other metadata tags or other metadata information within this too. For S3 tags, we can either store it as a single column or a complex object within a single column, or we can optionally call those out and index based on those tags as well. So it's very, very powerful to go through and do so. How you enable it? So first off, Vast Catalog has been with the product since 4.6. We've been adding some enhancements here and there as we go along with that. Again, it's a standard feature. There is no additional licensing that is required for this. It is literally turn it on, you have it available to go through and index it. So the way you go through and enable this is from the VMS GUI. You can also do this from the CLI as well if you wish to. But from the VMS GUI, you go into Settings, Vast Catalog, and say activate the Vast Catalog. That's all it is. Click down here, click the toggle, and activate that. It'll go through and it'll ask you some questions. First off, it's going to say how many frames do we wish to go through and use. A frame is going to be a snapshot of data that we're going to go through and load into the database there, how often we want to go through and do it, and then how much of that we want to go through and keep. Now, relatively speaking, the amount of metadata compared to the element store as a whole, is not going to be that terribly much, but it does consume some amount of space on there with that. So it's not unlimited by that, but it's not very large with it. So within reason, however, how much data you want to go through and keep is totally up to you. You do have the option here with this to go through and say, hey, I also want to store the file system snapshots along with this. So that again, I can go through when I index into the catalog, or I look at the catalog, I can actually then go through and go into a snapshot and get the file that is represented from that time there. That obviously is going to take more space because you're locking down that data in a snapshot. So if you delete it, it's going to still be there containing the snapshot, but you have controls over going through and doing that. So once you go through and you set that up, you determine how often you're taking these frames, whether you're going to keep the snapshots with the data snapshots with it, along with the how long you're going to keep this data around. You go through and just hit save, and it'll go through and do some processing. Now, this initial processing time will take a bit of time to go through and run. The amount of time it's going to go through and take is dependent upon the amount of data that's in there, the size of the cluster for this. Like anything, regarding, like if you're doing your initial replication or something like that, it takes that first initial run there takes a bit more time because it has to go through and do a bulk load of things, of everything that's in there. Now, as we go through and as those additional frames are run after that initial processing takes place, that happens relatively quickly because, like snapshots and like replication, we can determine very, very easily the delta of data that needs to be changed and only modify or only update those entries that have data that has changed. For that. So the initial load may take time. It could take, likely will take, a few hours to go through and do that initial index as things get loaded up. Again, it's going to be very much subject to the size of the cluster, the number of files and objects that you have on there, with that. But once that's done, then it's available to go through and use. Now, there's some other additional items here you can do, and you can see that on that screen there, is that if you wish to go through and define some custom tags that you want to index explicitly. So with things like the S3 tags, as I mentioned, those can be stored within a single column of single tags column to go through and put them all together. It winds up being a complex JSON object in a single cell, so you pull out the whole JSON there. But if you wish to go through and index this as a specific column, you can do that by just adding these user-defined attributes for there, where the type is going to be tag and the column name is going to be the name of the tag that you have in there, and then you can search these for this. Now, this doesn't have to be done initially. You can add these tags later on, and they'll get brought in the next time that the index runs, the next frame goes through and runs. So definitely not something you have to do first. You can add those in later. So once you have things set up and it's there, how do you get to that data? How do you get to this index of your data of your element store of your cluster to determine what you have within the system? So there's a couple different ways of going through and doing that. We provide first off through the web UI. The web UI has a very powerful utility to go through and say, hey, I want to look at these files here with some simple ands and or statements to go through, identify the data that you want for that. We can do this through the CLI. So we do have a CLI element, a couple different variations of a CLI to interface with this. There's a Python SDK we can go through and utilize to access the VAST database. We can make use of calls directly to the REST API. To go through and get that information as well. The most interesting one, though, is the query engines with that. Again, it is a database, so we could write SQL directly against it, but the query engines allow us some additional flexibility. We'll talk about that on how to start. So the initial access here, if we're using the web UI or the REST API type interfaces there, all this requires is VMS access and permissions. So if you have a user that is able to log into VMS for that, or has the right permissions within VMS to go through and access the database or the databases that are on there, that's all that you need. You don't need to go through and set anything else up for that. You can go through and make queries directly against the REST API. And I'll show you some examples as to how you can go through and do that. Anything else, if we're talking about making use of the query engines there, we would need to go through and we would need to make use of the access key or identity policies and create some S3 access keys for users to go through and interface this. This is a little different method for it, whereas if we're doing it through the REST API and the web UI for access, we would be going in strictly through the VMS management interface on the VMS network or the management network. This other access here is going to come in through the VIP pools. And this is where things like the rest of the database makes things very powerful, because we can spread these queries out, not that necessarily the catalog needs it, but other database operations will make use of it much better use of it there. But we can go through and spread these out across the VIP pools on the front end CNOT. So you would need to have access into one of the VIP pools for that from whatever client machine you're going through and running this. So setting this up, again, is going to be relatively simple to go through and do, and it's outlined in the documentation for VAST. But basically, the process is you create an identity policy, you associate a user with the identity policy, and then generate the S3 access keys for that particular user. So let's talk about what needs to be done here and how that gets done. So this screenshot here, I'll point this out. This is from 5.3. This is the current release version of that. The screen, if you're looking at 5.2 or 5.1 or 5.0 for that, this screen might look a little bit different, but generally the concept is still the same. The flags are still the same here for that. So in order to go through and create a identity policy, we navigate to the GUI. Or however you want to go through and create your identity policy, navigate into the GUI, go into user management, identity policies, and create a new policy. The policy is going to be, call it whatever you wish to go through and do. In this case, I'm using VAST catalog access, but we need to grant it some rights. Now, there's some special rights here, some special actions that are used, specifically the S3 tabular query data access that is needed for being able to do these types of queries there. So we need to allow that type of action to occur for that. And then we can go through and we can specify specific resource. Now, the vast catalog is, even though we're accessing over S3 and it is a database, it is treated special. It is treated separately, meaning it doesn't show up necessarily as a bucket listing or a bucket that's listed. It doesn't go through and show up. It's not a manipulatable database. It's fixed. So we need to give it specifically access to the vast catalog bucket is the database that is used for this. So we go through, we create this identity policy, say create and save it, and then we go through and we assign this to a user. Now, this user can either be a locally defined user, meaning I've created a user in one of the local providers, a local user on the cluster on this, or it could be a user that's tied into Active Directory or LDAP or something like that. But what we need to do here is we need to go through, we need to query for that user, locate that user for this. So in the case here, I've done a search for my user called catalog user. And I'm going to go through and I need to generate some S3 keys for this. I can come here and say, click on add new key. And again, your screens may be different depending on the VAST version that you're using, but it's the same kind of concept. And then we go through and we select which identity policies we wish to go through and use via this drop down here. So we put those three things together, and this would allow us to go through and use those queries as this user to use those keys as this user to access the VAST database. So relatively simple to go through and set up. But let's talk about how we can go through and how we can do some of these other queries there internally without going through that process. So let's start with the web UI interface. So first off, for the web UI interface, it's going to be very simple and intuitive for this. As the VAST catalog, as I mentioned before, is a database within VAST, as in the VAST audit log, very similar concept there. But we would go through and within the GUI, we navigate down to database, which is an option, VAST catalog, and we'd be presented with a screen, and we would have a query panel that we can go through and open up. We also see in here, the tenant that we're going through and querying, because we do maintain isolation a bit between different tenants. For this is part of our secure multi-tenancy. I don't want tenant A to be able to search catalog data for tenant B or tenant C. So we do isolate those out. We do that here. We represent that here in the GUI as well. So we would select which tenant we wish to use. If you're not using multi-tenancy, it's always going to be default. For that, and then which frame we're going through and using. By default, the catalog, these queries will default to the latest frame. All the queries will default to the latest frame. There are options to say, hey, I want to use an older frame for those if I want to search older data on this, but always go with the most current one that we have. And then from there, we have this nice drop-down menu that gives us our list of columns. Am I searching for the UID? Am I searching for creation time of a particular file? And then what type of operation? I don't want to, say my UID of 33443 or my Windows SID of this or my username of this. I can go through and do that. I can say my creation time is after a certain date. So we would put these together, and depending upon how we set up these queries, each condition we add in is going to be treated like an AND statement. If I want to make an OR statement as part of that, I can just attach that together with those, and it'll go through and run the query. And we'll go through and execute this. So here, I'm looking for all the files created by UID 33443, which is my NFS user ID on this. And I'm looking for all the files that I have created since January or since April 1st. So we'll go through, it runs the query, and it pulls out all this information. Now, within the VAST catalog or within the GUI, it's going to go through and show us all the columns, all the fields that are available there. So we could scroll back and forth on this menu that gets presented here and see all the different fields that we want. For this, I can also go through the drop-down menu or the column menu here. I can select which columns I wish to go through and have displayed. So again, we can look at this, we can get these results based on those queries there. And if I want to, I can go through and simply by right-clicking anywhere in the screen here, I'll get an option to say, hey, I want to export this data either as a CSV file or as an Excel spreadsheet that you can go through and import into something else. So, pretty simple, easy to go through and use. with that. So again, pointing this out here for 5.3 specifically for this is that we do have the notion of a cluster admin and a tenant admin. Cluster admins can go through and query per tenant. They can query any tenant in the system. Tenant admins are limited only to their own tenant if you're using those. Prior to 5.3, there wasn't really the notion of a cluster admin for that. There's other restrictions in there in terms of some of the roles as to where things can be queried, but everyone effectively is a cluster admin in 5.2 for that. So again, very simple to go through and use. You can do some basic but pretty powerful queries for these here to get this information out of the system. Again, it's going to be updated as often as you're taking those frames. So that's one option. Let's talk about a command line option. So command line option, we can make use of an external tool called VastDB CLI. So this is different than the VCLI. The VCLI is really more of an administrative tool. It requires you to log into the C node and execute some things. The C node using VCLI. We're not providing an interface to the catalog through the VCLI with this, but we do have this utility called the VastDB CLI, which is available from our GitHub repository. Go to github.com, vastdata, VastDB CLI. Has some setup instructions, how to go through and run this. And this CLI command here is actually generic enough or designed in such a way that it is usable not only for catalog but also for audit, but for all of the other databases, any other database that might live on Vast. There'll be some initial setup where you have to go through and provide that S3 user key or that that S3 access and secret key for that, pointed to the VIP pool as part of the setup. But you can go through and run these commands here. Now, in this case here, this is a very simple command that I'm running here where I'm telling it, hey, I want to go through and I want to query the catalog for this. And I want to look at the path of slash. Again, this is going to be the default tenant here because I'm not specifying any other tenant. So it's going to look at the entirety of the element store, and I'm looking for files that are greater than 1 terabyte in size. So it gives me a list here of this here. Now, I know I happen to have more files out there, more objects out there that are larger than this, but at least with this query here, it's only giving me the first 10 that it has. And there's options to tell it to give you more. But gives you an example of things here as to that. And so again, some basic data: where it's located, what the name of the file is, when it was last modified, who the owner of the file is, what is the group that is with it. And you can set some flags as to what data you actually want to have a return. So another option to go through and do without having to set up a lot of different things to run. We do also have the Python SDK, or the Vast Database SDK, for this, which allows you to go through and run these types of queries from a Python script for this. Again, our GitHub repository here is available. If you already have Python set up and you want to go through and do this, just run pip install vastdb for this. Now, here's an example kind of a script that you can go through and run here. So it's a Python script here. I provide it with my information, my connect information here. This is the VIP pool I'm going to utilize for access, my access key and secret key for this. These are temporary keys, so I don't care about having these out there. They'll be gone by the end of the day anyways. And then the connects here, and then what types of objects we're going to go through and look at. So we're going to go through and look at, here's the total number of objects in the element store. I'm going to go through and take a look at the types of objects that I have here for this, and display the different information for that. So this will go off and run. And it tells me, hey, I've got this number of different objects in there. These are the total number of files that are in there. Why are these numbers a little bit different? Well, because some of these are some of these may be block devices, some of these may be other items that are out there, but these are files or S3 objects specifically for the second run. And then the different types of things that are out there. So I can see here that I've got files, directories, I've got database tables, I've got blocks on here, block devices on here, because this is 5.3. We have block that we can go through and share out as well. So Run goes through and runs this. And this is another pretty good option to go through and do that and make use of that as well. If I want to go through, I want to query the REST API itself. For this, we can go through and do this. So if you want to see what options are there for the REST API, you can go through it on the VAST cluster. If you go to the VMS login screen, but instead of logging in, you would go through and just have the IP/docs. There, you'll get a documentation for our API interface. We would want to go through, and we would go through, if you scroll out into database, there's entries in there for catalog specifically. Any of the queries we're going to go through and make are going to be against the big catalog config endpoint. Why it's big catalog config as opposed to big catalog, more for historical reasons when things were put in for that, but it's big catalog config is the REST API endpoint that we'd want to go through and use. So you can make a query directly against that. If you want, an example or a quick and easy way of doing it, we do have a downloadable utility as part of this SDK called VASPI CLI, which would allow you for scripting if you wanted to just run a couple bash commands against this rather than having to write your Python script. For that, you can go through and make use of this here. And I have kind of an example here of what that command would look like using the VASPI CLI. As part of the SDK, again, we have to go through and we have to provide VMS credentials because we're going into the REST API. So you'd have to, I'm using the VMS user. This is the address that I'm using for the VMS IP address. And then the VMS password happens to be the default for this case here. And then I'm going to go through and I'm going to construct my command. VAST CLI, I'm going to do a post for this. I want JSON output coming as a response. I'm going to go through and query data. I only want the first two entries that I get back. It was nice because it fit on the screen for this. I'm going to look at, pwags mix is the directory, and I want to get the parent path, the name of the file, the last time it was accessed, and the size of that particular file. And I'm going to look for any file that was accessed more than 2 days ago. Okay, and it gives me out some of the results here. So I've got two different files here that were created, they were last accessed more than 2 days ago for this. So these two files there, there's not a lot of activity on this directory, so these files were last touched on April 29th when they were there. They're not, they're just touch files, so there's no space for them. So you can see another example on going through and accessing things there. So, but those there are pretty useful. You can go through, write some basic commands to go through and do things, but that's not necessarily where a lot of the power lies in what you can do with the database. So let's talk about some more complex things where we can actually do a lot more information. So if we make use of a query engine, so a query engine might be Apache Spark or Trino or something else there, we can go through and we can leverage the power of these query engines to do a couple things. We can go through and improve performance, first off, of this. And this can be done, again, either for the catalog or for the audit logs or for the database in general, where it can be distributed out across multiple engines. So if I'm writing complex queries to multiple tables, multiple databases, these query engines can have multiple query engines out there. They'll spread the workload. They can also go through and communicate across multiple C nodes there to give us more throughput, more processing capabilities across the cluster, and really leverage some of the power that we can go through and have these very complex types queries to go through and utilize those. So they also, the advantage of some of these query engines is that they also have more built-in functions. So if you notice, for these, I have to go through it. I can call out, ands and ors, look for particular columns for this and get data back. But, I want to go through let's say I want to know what the count of a directory is in there. That's a little more complex. It takes some more additional types of things that need to be done there. That's what these query engines are really, better for this. With the other options, with doing the VCLI, you'd have to go through and say, hey, I want to retrieve all these columns for this, and then I have to manually count each one of those up with the results and then spit out the results there. These query engines will do it as part of the query for that with something like sum. For this. So I'm not going to go through on how to set up Trino. It's going to be very similar to the method. You have to go through and set up your access key, user keys, and things like that for this to allow those to communicate with it, a little bit beyond what we're going to be able to do in this webinar here. But if you want kind of an example there, we do have a nice utility or a nice baked-in demo referred to as catalog in a box that kind of demonstrates how this goes together. Definitely not made for production use by any means for that, but if you want something to kind of poke around and play with there, we do have a thing called a catalog in a box. Talk to your local sales team, talk to your local SE about how to go through and obtain that. Catalog in a box is nice because it's literally, okay, what's your VMS IP, what's your access key, what's your secret key, okay, good, go from there. And it includes some other things like Grafana dashboards and such. So let's talk about, run some basic queries here. So we're going to go through and run some basic queries for this to get some data out of the catalog here. So I'm gonna make mostly utilization here. I'll do some of this initially again through the VMS GUI, but then I'm going to do a lot of this with a utility called QueryBook, which allows me to write SQL queries kind of ad hoc. For this, it does talk to Trino, our Trino setup in our lab, and then we'll give us that. So we're gonna go through and just say I want to look at the attributes in the catalog. I want to go through and give like the total number of files and directories in a cluster. Give me the top 10 largest files in their owner, and show me the number of users that are using the most space. So let's go through and let's do that. So again here from the GUI here that I'm logged into a 5.3 GUI as administrator. Where all this is going to be located is in our database VAST catalog for this. So we have these queries here. If I want to go through and I want to execute a query here, let's say I want to find a column. I want to look for, again, we'll use mine here. My UID here is, and we're going to say 33443. I'm going to go through and add this into this. I'm going to execute this command here. This is going to run real time. So it's going to go out and query the database here and give me all the files here. It does limit things, and I'm not doing kind of sorting for this, but kind of gives you an example as to where you would where you go through and do some of these queries there. And for any one of these, I have all these other options here for these different column names, things I can go through and search for when I'm looking for things there. Again, if you haven't already enabled, if catalog is not already enabled, you'll say catalog isn't enabled in here. So you need to go through and set this up. You can do this under settings, go click on settings, VAST catalog, and this is where we would either turn on or off catalog, where we set how often we go through and take catalog copies or set the frames, how often we're doing that indexing, that's on, how long we're keeping that, and are we storing snapshots for the data with this here. So in this case here, this is our lab cluster. We're taking them every 15 minutes and storing an hour's worth of those as well. We also have here, again, some of those custom tags, and I'll show you these in a query in just a moment here for those. So let's take a look at some of the basic queries, that we have here. So these are, and I'm going to point out these are all running real time here, so there may be a little bit of a delay here with some of these queries because some of them are processing quite a bit of data, and as with live demos, things happen. So hopefully we don't have any problems here. But I'm going to go through it. I'm going to say, hey, I want to describe the catalog here with the table. The Trino config has this identified as var 204 is the machine it's talking to. So we're going to go through, we're just going to run this query here. It's going to go out, communicate to the database, say here, give me all of the columns that are available, and I'll see all of these here that we can go through and query. So I have all the standard ones. I click on next, I still have all the standard ones, and then I have some of these additional ones here that were defined as custom tags, where if I come back here to the catalog, I'll see that these were ones that were defined here as custom tags. Okay, so let's go through and let's run a little bit more. Let's run one here. Let's again look at what's available in the cluster as a whole. How many files do we have in here? So we're going to look at total number of files and total number of directories. So we're going to go through and run this query here. Very straightforward, and it doesn't. Why does it not like that? Oh, I love it when it doesn't. Let's run this again here. Come on. Didn't like when I had something highlighted there. Don't know what its problem is. Okay. So it'll go out and run this query here, and we're going to get a count. And this is going through, and again, this is real time. So we're going through, looked at that, give me a count of all of the files and all of the directories in there, as well as the total size of everything within this particular cluster. So that took, this runtime here took 7 seconds to run. Think of how long it would take from a find command to go through and give me a count of every single directory, every single file. And this not only includes the one share. This is the entirety of the element store. So it's very, 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 very quick, very, very fast. Let's do something a little bit more. Let's say I want to look at the 10 largest files that are on the cluster, and I want to know who owns the file, what the name of the file is, and where that file happens to be located. So we're going to go through and run this. We're going to say, okay, I want the owner name. I want the parent path that it is, the name of the file and the size of the file for this. And we're going to go through and run this query here. And it's going to go kick off. It gets sent off to Trino. It'll go through and run the query here. And hopefully it comes back here in a second here. So this will come back relatively quickly here. And it took us 14 seconds to get this information where I see, hey, I've got these large files here for this. So I've got some files that are, about 2 terabytes in size, terabyte and a half, some a little more than a terabyte. These are the owners of the files here, and these are the locations of each one of those files. So again, it took 14 seconds to index the entirety of the element store. Let's talk about who has the most space on the system. Which users are using the most space in the system? So on the top 10 consumers. Now, the user here is going to be, who owns the file, who's the actual owner of the file. And we're going to go through and get the sum of all of the files that they own for this. We're going to group this by the owner's name, and we're going to order this by the size here. So this is more than just going through and doing a query of everything there. We're having the query engine go through and do this sorting and the summation of things there. So let's go through and run this query here. Again, this is going to be live against the system. And it's going to come back. Took about 6 seconds to go through and runs. And it tells us that, hey, okay, we have, the owner, user vast data, owns a majority of the file. Now, this is in bytes. I'm not doing anything fancy like converting it to human readable form. We've got quite a few files owned by root, some that are owned by null. So that's somebody running as NFS nobody. And then some other users here that are using, quite a bit of storage on this particular cluster for this. Now let's take a look at some tags. Okay, so we know space. Let's look at some S3 tags. Let's find some files out there that have some particular tags or have some tags. So this is going to go out. It's going to give me the name of the file and show me what the tags are for this file. Again, I'm not looking at any particular pattern or anything with this, but we're going to be able to see here's the path, here's the name of the file or object, and here's the S3 tags that are associated with it. Someone is saying, oh, hey, there's an actor tag with this. Some of these are saying, hey, this is the file that's been processed. There's some key values that somebody put in here for these here. There's some project that somebody put out there. So they've set these different tags there, and these are what's available. So this is what you'd be able to get if you weren't indexing those tags directly or specifically for looking at a particular column. We'd go through, if I just pulled user tags, I would get this JSON object that has these multiple fields with it. But let's say I want to look for a specific tag. So let's say I want to find, hey, for source here, I want to look at the source tag there. So I would want to index that out. Let's go through and let's take a look at our configuration here. And oh yeah, okay, we already have this indexed out as a specific tag, as a specific column. If I come back to the available attributes here, I see, oh, there's a tag here. So I can query for that specific tag directly. So let's do that. Let's say I want to find all the files here, looking for the same information. I'm just going to pull user tags again out of this to give you to show that complex JSON blob there. But I only want to look for files, or give me the files that have their source set to openimages.net. So we're going to go through, we're going to run this command here. And of course, it's on no, because I have it highlighted. That's why. Query book doesn't like when I keep things highlighted when I run the query. So it goes through and it gives me these here. And I'm only asking for 10 files, but it's going to give me, here's 10 files in, I'm not specifying order, it's just going to be the first 10 files you find that all have this tag on them. And I can change it. So let's say I want to use, something else. Let's say I want to say, tag processed. And I want to go through and I want to query for that. Let's say tag processed equals yes. And we're going to go through, we're going to be able to run that query there. And it says tag process is not a tag that I can go through and look at. I should have taken a look at that before I ran that. So let's see, tag source, we'll say tag project. Tag project, and I want to go through and say, do I have a project one in here? I may not have one of those indexed there. So I probably shouldn't be doing examples with specific ones as we're going here without having something already planned. But I could go through and change, the tags here and get those kinds of queries with that. So again, by using using a query engine, we can write those kind of basic type commands. Now, if I wanted to go through and I wanted to run some of those queries here via a different method, let's say a Python script or something there, I'm going to run some of these commands here using some of the examples that I had before. I'm going to go through and I'm going to run I'm going to go through and I'm going to say, hey, I want to look for all the files in here that are greater than 1 petabyte or 1 terabyte in size. So I'm going to use this using the fastdb CLI command, catalog query for this. This is going into in that. We're going to go through and we're going to run this. And it's going to go off and give me, all the files that are starting at the element store slash, and give me all the results for them. So it gave me all the objects that were out there that were of this size. Now, the one thing with this is that I am not specifying what type of object that I have in there. So an example here, if I look at, so these are the top 10 files with tags of this size. If I looking at the top 10 files specifically here, okay, if I'm looking for element type objects here, I am not seeing one of these items in here because the objects that are being returned here is that this large one here, this 5 terabyte one, is actually a block volume. So I would go through and I could do a query against a block volume and see the size of the block volumes that I have out there. So, some different options there. We need to be cognizant if we have multiple types of data out there, what it is we're looking for. Let's say I want to go through and I want to, run this using the vastpy CLI command here. So this will be using the REST API. I'm going to run a command here with that. So I'm going to go through and hold on a second here. Copy this and paste it in. So I'm going to go through and run a command here. So what I'm going to go through and do is I'm going to do a query here. I'm going to look at all the files here that I own that are greater that haven't been touched in the past 2 days for this. So looking at my particular directory, very similar to that one command I ran in the GUI. Again, I'm going to go through because this is an API command. I'm setting my access method that way using this the vastpy CLI, which is a REST API interface. We're going to go through and we're going to run this command here, and it's going to give me that information back for that. So similar to what I showed before, but it gives me that. So different ways of doing things. So we have those. We got some basic queries. Let's look at some more complex ones. So for these complex ones, restart the slideshow here. Let's look at some more complex queries here. So let's go through, let's run a utilization report. Let's say I want to know who's using the space in there a little bit there across this per owner. Okay, we ran something very similar. Let's make it a little more pretty to do that. Let's look for stale data. Let's look for data that hasn't been accessed a certain time and is older than has been accessed with a certain period and is larger than a certain size. Let's look at data growth. How are we seeing data that is growing in terms of how much new data is being generated in a particular directory? So we're going to go through and run some of these queries here. So let's run this utilization report. So we're going to go through, and again, this is where query engine becomes helpful because I can go through and I can say, I want to look at total files and I want to do some formatting of this here. I want to look at their kilobytes used. So rather than getting the size in bytes, I want to get the size in kilobytes. For this, I want to get their average size, and I want to see, how their oldest data is based on the creation time, and when their last access time. So it gives me a report based on this information here that is useful to us as to how they're doing it, how much data they got, how old their data is, how much they're accessing it. So we can go through and run. So I'm going to go through and run this query here. And again, this is going to be real time for this and doing this kind of formatting that's going on. So it's going to go through and run off and do some processing there with the query engines to run. And I come back, took 11 seconds, and it says, hey, we have these files here. So these are the owners of the file. They have this amount of space here that their amount of files they're using, how much data they're using, their average size, oldest data and newest data. Based on these types of this type of information here. Let's do this. So let's say I want to look at stale data. Let's say I want to say, I want to look at data that has not been accessed in the past year, and I want to see, who owns it, what the path is for this. So we're going to go through and say, hey, I want to get the owner, their path, their name, the size, when data was last accessed for this, and I'm going to say access time is greater than 1 year ago. So a little different way of formatting things for this. We're going to go through and run this query here. And I'm going to limit just to 10 to this for this. We can do other things with it, with these kind of types of queries. But I'm going to see that, okay, the vast data user, mostly in this directory here, has quite a few large files with this, that their last access time was more than 2 years ago for this. So that might be grounds for going through and saying, maybe I can delete that data, free up that space somehow if they haven't gone through and accessed it. We got a much more complex query here that we can go through. We're talking about data growth here. So this is basically going through and we're looking at, in each directory, how much data we are looking at the last modified time of this. In the last time we're looking at the last modified date for this, for how much data has been put into these particular directories from this. So we can use this to maybe track a runaway process that's going through and writing data in the system, but it's going to go through and summarize these out. So we'll run this query here, and it's going to give me these directories here, and this is in no particular order for these here. So this is how much space somebody has consumed or ingested into this particular directory, from this period in the last 10 days. Okay, so we're able to look at the modified time, say that this data has been changed in the last 10 days, so we know there's something that's been there. Now, it's not looking at create, it's not necessarily taking into account, how much data was there before. That'd be a much more complex query. Just saying these are files that have been modified in the past 10 days, and we're going to go through and summarize all those up. So, some more complex queries for those gives you some very powerful utilities to go through and utilize. So with that, I've got, just a couple more things here. Let's talk about some other visualization options here. So we can also go through and not only do this as kind of these queries that we want to do, but let's go through and let's talk about some visualization. So we can utilize the vast catalog and plug this into things like Grafana or plug this into things like Superset to go through and give us some visualizations of these. Grafana itself does have the ability, we do have some dashboards out there that emphasize this, kind of design these calls here to go through and give us some of these visualizations. You can set these up with Superset as well. So let's kind of take a look at what those are. Let's take a look at the vast catalog dashboard here. So this is Grafana here, where we're looking at this same cluster here. So we can see that there's 621 million files, 284,000 directories. This is a breakdown here of the user that has the file or using the most files, a histogram of the file size that we have on there, how often files have been modified for these largest files, directories with the most files, largest directories, the extensions of this. So I've got 104 terabytes of files ending in .cram. 20 terabytes of files ending in .tb, 1.4 terabytes of files that don't have an extension on them. So we can get all these things in a very easy way to go through and see these. We can also go through and some of these other ones we can take a look at, files created within the current hour because we're looking at the seed time of particular files modified within the current hour. We can get all this from the catalog based on just that information there. Along with some of these other things. We have some very powerful visualizations here. If we couple this with something like Superset for this, we get some other utilizations of these. And I'm not going to go through into how to go through and run a few of these queries here, but we can kind of get some other graphical representations of things here. Again, 621 million files. This is a little more graphical, different breakdown of the type of file by extension here. for this. So a majority of cram files and then GZ files and so on and so forth. So we can plug these into multiple different locations to give us a very powerful insight into the into your system and the data that's on there. So with that, I'm going to conclude here with that. I do thank you for your time and your attendance to this. Again, if you have questions, please reach out to your local sales team, your local SC team. Again, if you wish to go through and make use of Catalog in a Box, again, is going to give you at least a taste of what some of these query engines can do and things there. A nice, simple, self-contained VM for that. Talk to your local sales team, your local SC team, and again, thank you for your time.
All right, and Phil, before everyone signs off, we do have some questions that came in, and these questions were such that it was better for you to answer them live. So if you want to take a look at those while I go through a few last things, I'm going to put in the chat a link to our deck for the presentation from today. I know there was a lot of really great screenshots in there. We will, as I mentioned, send out the recording along with our invite for our next webinar. Our next webinar is going to be on really like what's new with VAST. So we're going to talk through an overview of 5.3, some major features in there, and also talk a little bit about 5.4 and what's coming, and just generally want to give all VAST customers a chance to hear a little bit more about the impact of these releases and the great things to take advantage of. So with that, Phil, I'll toss it back to you since you've had a chance to look over those questions and maybe you can tackle some of those.
Sure. Yeah. So first question is do catalogs create indexes on the defined attributes listed when enabled or some other way? So they do create indexes. They do create columns when you define those attributes that you want to look for. For that, they do get taken care of when the next frame is run. So it's not something that's done immediately upon defining that. So what I mean is that within the VAST catalog setup, if let's say there is an S3 tag that you want to index separately or have a column to search on separately, you would add that in the next time. You would add that custom attribute in there. The next time that the catalog captures its frame, it would then make sure there is a column or create a column that you can go through and index. So if you're doing that quickly and frequently, that'll show up there. That if there's no attributes that exist on there, that's fine. You can predefine them and load take data on. So it doesn't have to be there at any particular time. It will just be generated when it gets brought up. Let's see, Grafana link for the dashboard there. Again, if you go to grafana.org, there is with the dashboards there under the VAST data one, there are links to those dashboards there. I've got the link in the slide deck, so when Kristen sends those out, you'll have those links there. So access. Question is, access is when last touched. So access is going to be a specific metadata attribute that determines when a file was last accessed. This could be the file was actually read, or by definition, if it was updated, access time is updated there. But access is when a file is last read. Depending upon what you're set up for that, the system may or may not be tracking those. There is a attribute within an entry within the view policy that determines whether we're going through and tracking and updating access time on those files. The reason that we don't always go through and update access time for all the files is that, especially in a read mostly environment, every access then would require a metadata update. And that could generate a lot of metadata updates. So there's controls there for recording the access time. Number one, do you want to record access time? And then number two, how frequent do you want to record it? Where you could record it, just once a day, meaning if a file is accessed one time during a day, or 100 times during a day, or 1,000 or 1,000,000 times during a day, it just updates once for that access time value. Or you can make it so it updates every single time you go through and touch the file for that. So we can go through and set that, as to what we want to do. Looking at, can we isolate or limit users per VAST view for the VAST catalog data? So Today, the access to the vast catalog is a all or nothing for access to read into the catalog. Again, you define specific users; they have access into that particular view for that. In order to go through and do that, um, in order to go through and limit that for there, we are looking at, I don't know the status of this for this. This could be near term, could be longer term there, but we are looking at being able to put controls for a per row access for those to be able to limit some of those queries there to give you a little more granular control as to what data someone can access within the catalog. Um, for that, so not directly within the identity policies to limit. Say I can only query based on these particular paths. You could easily go through and take that, go through and write or some kind of wrapper around there to limit what somebody could search for through an API. But at least with the access user identity policies, things like that, there's not a mechanism. It's if you have access to read into the catalog, that is that's the only options you have.
All
Okay, and
right.
I see you provide a dashboard that was posted in there, so thank you.
Yes, and also was able to get up to our link for our next session. So if you would want to click on that and then register for upcoming session, we would love to see you there. And thank you so much for joining, and we hope to see you again. Take care.
Okay, thank you, everybody. Have a good day.